All right, this is Team 7. My name is Ishfar Ahmed, and here with me I have Javier Cervantes, Anthony Melgar, Abel Milano, and Michael Peterson. And for our project, we are going to be touching on hydrogen fuel cell controller systems. Next slide.
For our outline, we have the introduction, motivation, objectives, background, controlling the input and output, conclusion. Next slide.
So for this project, fuel cells are becoming a popular source for electrical power due to the fact that it can operate at higher efficiencies than other forms of energy sources. They can convert chemical energy and fuel directly to electrical energy with efficiencies capable of exceeding 60%. Furthermore, a fuel cell generator has the capability to generate 2 to 3 times more efficiently than a gas-powered generator. Why a gas-powered generator? The reason being is that this is the most common form of generator in the market. Additionally, energy produced by a 1 kilogram hydrogen gas is very similar to energy produced by 2.8 kilograms of gasoline. So you can see the ratio here is more on the positive side for hydrogen gas. And here on the right-hand side, we have a model of a basic fuel cell system, which we will elaborate more on in our future slides here. Next slide.
Here we have our design motivation: to take a hydrogen fuel cell and make it more efficient, to not expend more hydrogen than what is required, provide a constant flow of air when needed. Next slide.
We have the objectives for our project. Our main goal is to develop a control system that shows the overall operating system for safety and efficiency. The goal is to control the flow of hydrogen, the intake of air, the output of the current. And the main objective at the end is this will assist with efficiency, save loss of fuel, create an overall safety of the equipment. Down below, we have a basic models of our system. And the main goal here is to show our outputs and what we were trying to get for a basic model of our project. Next slide.
So now let's go on a little bit of background with some generators, specifically electrical. So the electrical generator will take mechanical energy and from an external source, then it will convert that mechanical energy into an output of electrical energy. This is done by capturing a power of motion and turning it into electricity, and it makes it into electricity by forcing it into forcing the electrons from an external source through an electrical circuit. Now let's give a little background on hydrogen fuel cell. Hydrogen fuel cell works very similar to a battery, except it doesn't run down or need recharging. It also is composed of 2 plates, 1 anode and 1 cathode. Those plates are then separated by an electrolyte membrane. The hydrogen will pass through one plate, the anode, and the other will pass through, the oxygen will then pass through the cathode, the other plate. This then will have the positive particles pass through the membrane while the electrons cannot pass through it, which then forces the electrons through a circuit to generate a current and heat.
So the intent for controlling the input and output of the system, the inputs will be the hydrogen and the air supplies, and we will be using a valve and fan to control the amount of those that are entering the system. A feed-forward control system will manage any disturbances in the air pumping system and will ensure that the flow is constant for no drops in voltage. The feedback control system will ensure that the ratio between hydrogen and oxygen is maintained so that the fuel cell can operate at the maximum efficiency. The outputs for the fuel cell will be electrical energy, efficiency, and temperature. And a proportional integral derivative temperature control system will be used for identifying temperatures that are too hot for the fuel cell to ensure that it can safely operate. The outputs measured will end up being the electrical energy / power produced, the efficiency, and the temperature. The bottom right has a block diagram of the different control systems and fuel cells that are in the market right now. Next slide.
All right, so in conclusion, for our project, what we are going to do is how we're going to design an architecture for a controller for the fuel cell system that we are going to be touching on. And we are going to consider the power management for our testing purposes in a simulation setting. And from that, we will end up obtaining results from the simulation and use the dynamic equations to determine the flow of the hydrogen needed along with how much intake of air will be required. Next slide. And that is all.
I'd like to thank you for listening.
Thank you.
Thank you.